Hello, everybody. Welcome to HTM Hackers Hangout. It is December 7th. I'm Matt Taylor from Numenta with your monthly live update on what's going on in the HTM world, the HTM community, coming to you from Watsonville, California. There is a link to the forum thread where we post discussions and the things we're going to talk about here. So I was going to talk about a few things that I've been working on, and then just open it up to community questions. I was hoping somebody from research would pop in. We have a new intern I wanted to introduce, but I haven't seen him yet. But when he comes online, if and when, I'll introduce him. And so a couple things that I've been working on. As you know, I'm not one of the neuroscientists on the research team. I'm the community manager, and I create a lot of educational material. So I'm working on educational material to back up the two papers that we just released, the frameworks paper and what we call the Columns Plus paper. So I'm working again on the frameworks paper. There's another HTM video. I'm trying to come up with this visualization of the 1,000 brains theory that really sort of shows the difference between the classic hierarchy idea and the 1,000 brains hierarchy idea, and some visualization that really emphasizes the lateral connections and the importance of the lateral connections. I've been working on this for a long time, and as a part of that, I really dove into trying to understand sensory projections in visual and somatic cortex. So in the link down below, you'll see that I dove into this idea of quilting in the cortex. The term quilting is not a neuroscience term. That's something that I or Mark or one of us came up with when we were talking about this. But the interesting thing is that there's all of these projections of from the sensory field onto cortical substrate. You can see it in V1, V2, V3. There's a projection of the field of view. And in S1 and S2, there's a projection of the entire body space onto cortex. But as you go up the hierarchy, they get weird and they get all mixed together, and it doesn't. They're not like totally continuous. And then there's these other types of projections that are more having to do with how different features that are being extracted from senses are projected onto the same topological substrate. This is like the tiling, or not tiling, they call it like the striping, of like ocular dominance, binocular dominance, or between different types of cells and somatic input. Anyway, there's a lot of different things going on here. So it was an educational experience for me because I didn't know what was what. So that whole thread is basically me, a path of self-discovery for me, trying to figure out what's going on here. And so if you want to follow along with that, I didn't find anything that lit up any light bulbs in the research team or anything, but I got things better in my head, which was the whole point. I wanted to come up with this visualization, but I'm still working on it. It hasn't manifested itself yet. So there's that. And the other thing that I've been working on recently is working with Mark Brown, or BitKing, on the forum, because Mark Brown's been talking about his idea of hexagonal grids and how they map to mini columns for a long time now. And I've never quite understood it. So I was like, I'm going to dive in and understand this. So Mark and I went back and forth for a long time, and he's been really patient with me, really helpful for me to understand this idea. I mean, it goes back to this 96 book, The Cerebral Code by William Calvin, and how some of the ideas in that about emergent hexagonal grids based on the interactions between pyramidal neurons might be at play within HTM, or might overlap with HTM. And specifically, I mean, there's some interesting things in this thread that Mark and I exposed. So we started chatting back and forth in private messages, and eventually we got to the point where let's just make this public. So we cleaned it up and made it public. So it's all me and him going back and forth, how do these ideas of hexagonal grids and HTM play together? So there's a lot of discussion about that. And the most interesting thing, I think, is that Mark explained to me that I liked, was if you have an SDR, if you like a mini column activation in some big cortical substrate, ignore the cortical columns, just say you have a big population of mini columns and cells within them, and you have a mini column activation that's driven by feed-forward sensory input. If you look at all of those mini columns, that's an SDR, and based on the geography and the continuous tractor model and the the idea that a hex grid can emerge based upon sensory input. Like you can look at that SDR and you can go like search around for these hex grids. So there's ways that you can find these hex grids and help them emerge and help them learn. Interesting idea to me. I talked to Jeff and Marcus about it both, but they're really focused on applying the ideas about the grittiness and the grid cell stuff at much lower levels within layers of columns and the interactions between columns. So they're not interested in looking at that right now, although I do think it's an interesting idea. And tons of credit to Mark Brown for continuing to push on that, because I love interesting ideas. So thanks to him for that. I don't see anybody from the research team online right now. So I guess we won't have a research update, but we do have a new intern. His name is Max Pollock, and he's got an account on the forum. So if you see him on there, I guess say hi. So I'm open for Q&A, and I'm going to open the mics. If you guys want to say anything right now, go for it. I'm going to look through the chat and see if anybody is asking any questions. Josh Rowe is asking about interfaces for brain, like BCI, brain control, brain interfaces, and I really don't know much about that. OpenBCI used to come to our hackathons, though. They've gained a lot of popularity. Connor Rusumano, I think, is their founder. He's talked at our hackathons before, and they make these, setups, EKG type setups, and make it really easy to hack into them, and so it's interesting stuff. But I do not know how HTM would work with that type of thing. Mark says Mark's on chat right now, and he can't join, but he says he's working up a post to show more stuff on HTM and hex grids in the visual thing. That's too detailed to bring up here. Josh Rowe is asking again about BCI stuff. Does the signal from NUPIC layers mimic what the brain is actually doing, or is it abstracted? It's abstracted in some ways. For example, we don't model interneurons directly. We do not create like instances of interneurons that are associated with mini columns. We model the effects of interneurons. We think we understand what the interneurons are doing and to form mini columns, and so we model the effects of them. The same thing in all of these grid cell stuff. And they don't really know. There's still debate about this. How are grid cells formed? It's very likely that interneurons are involved in that. It seems there's some reports that say no, it's not possible. They're too small. But anyway, the grids are too small, not the interneurons. But I think the jury's sort of still out on it. But there may be interneurons that work within grid cells, but we don't have to model them. If you understand what the interneurons are doing, and some systems, I don't think you have to model them directly. Do you think HTM can be modified to work with back propagation algorithm? So backpropagation is sort of a way to attempt to do like credit assignment, and then so let me point you to a few things. I don't know. Like our position here at Numenta is a backprop's not going on in the brain, and we don't need it for the HTM model. There's other ways that the brain's doing credit assignment. I've talked recently to Blake Richards about this, who's a theoretical neuroscience. Look at our podcast. He was the last podcast that we did. We talked a bit about this backpropagation and how it relates to the brain and whether the brain can do backpropagation. He has some ideas about that sort of credit assignment being done through apical dendrites, which is totally in line with the HTM world. So I think if there is credit assignment being doing, it's probably being done in that way. You might want to read, Mark Brown will ping you on this probably, but Mark, you might want to read that 3 visual streams paper, because that is along the same line. It sort of shows a proposition for how backpropagation might be done in the visual cortex with these 3 streams and the thalamus as a blackboard. So you might want to look into that, but the Numenta position is backprops not going on in the brain. We're not trying to model it. Hey, David Ray, good to see you. I haven't heard from you in a long time. Give me a call sometime, man. I also noticed, I was talking to Martin earlier. Hello, Martin. He's calling in from Taiwan. Let me give you a chance to say something if you want to bring something up. Oh, I could unmute you too.
Just a question about how temporal memory with atypical, proximal, gosh, what's the name?
Sequence memory, temporal memory.
I mean, temporal memory with external signal injection works.
External signal injection.
Yeah, like I always forgot the name. Like
Do you mean the lateral connections?
yeah.
Yeah. So we call them in the columns paper the lateral sharing between columns.
I mean, so I have read the algorithm of the normal temporal memory we have all been using, and it's basically extracting using the columns as sorry, it's using the active cells in the columns as the context to predict the next sequence. So how is this mapped to an external signal?
Okay, so I'm actually looking at this right now because this is it's in the columns paper, not the columns plus paper, but the original columns paper. And in the it tells exactly how to do it. But what they do is they take some portion of those distal inputs, and they get them from another column. So like their output is now their input, and so they first will come up with what many columns are active based on the feed forward input, and then they'll use the other input as a bias. But they'll be predicting basically in the same space. It's in the columns paper. I'm actually reading it right now, so I don't have it like fully formed in my head, so I can't talk it back to you. But if you look for our columns paper, why does the cortex have layers and columns? I think is the main one. But the details are in there on how that works, and we have simulations as well.
Okay, I'll look into that. Thank you.
Sure. Someone else is online. Is this, who are you? Hello. Phil. Nice to see you, Phil. If you have anything, pipe up. Otherwise, I don't see any other Q&A coming from chat. And there's like 18 people watching. So hello, everyone. Thanks for watching. I think we're wrapping up. Unless we have any more questions coming through, I'll wait for a few seconds. Oh, Phil says he doesn't have a microphone. No problem. I enjoy having them. It's a way for us to update, you guys, what's going on. So it's exciting times. There's a lot of stuff going on right now in AI. And I don't know if you guys heard my last podcast interview with Blake Richards. I thought it was really good. I said a couple things that were technically incorrect, but they were just misspoken. But Blake said all these things that I'm like, yes, I totally agree with all these things that he said. It's so great to hear someone else working in the field of theoretical neuroscience, coming from the field of neuroscience, that's so well aligned with sort of the picture we're putting together of the brain. It's very refreshing. So I'd recommend taking a listen to our last podcast episode if you haven't and you're part of our community. Otherwise, everybody have a wonderful holiday season. I will not be seeing you guys until January if you do celebrate, those Western holidays. No, David, that brain's not anybody I know personally. All right, we'll see you guys on the forums. Join HTM forum if you haven't already. Take care.